Okay, so we were discussing about product of vectors. Okay, there can be two types of product. There can be different types of product, like say product of two numbers is a number, product of two matrix is a matrix. Similarly, there can be two types of product of vectors. One is dot product, one is cross product. Okay. So I have taught you about the dot product, but I'll give you a quick recap of the dot product so that you remember important formulas related to dot product. Then we'll go into the cross product today. Okay. So dot product, let us say product of two vectors. Okay. So this is nothing but magnitude of A vector, magnitude of B vector, then cos theta. Cos theta. Okay. So what is theta? Like say, let me say this is vector A and this is vector B. So the anti-clockwise angle between A and B is called theta. So this is A, this is B. This is vector A, this is vector B. So this angle measured is always anti-clockwise in nature. So something which is moving like this is called anti-clockwise. Something moving like this is called clockwise. Okay. So the A dot B is equal to magnitude of A into magnitude of B is equal to cos theta. And A dot B is a scalar, or a real number. So it's a number only, right?
Yes.
It's a real number. Okay,
Yes.
it can be positive, it can be negative, or it can be a fraction. So you have natural numbers which are 1, 2, 3, 4. You have integer which are -1, -2, +1, +2. Then you have real number like 2.5, 2.6. So it can be a real number. So real number consists of everything. It can be integer, it can be a fraction. Okay, then you have imaginary numbers. There are square root of -5. That is called imaginary number. There are different types of number. So this particular dot product is a real number or a scalar. So any number is a scalar. Okay. So that is one product, one property of dot product. Okay. Then another is like when theta is equal to pi. Okay. When theta is equal to pi, that means this is A, this is B. Okay. So the angle is pi. Right. When theta is equal to pi, A dot B will become A magnitude, B magnitude, then cos pi. Okay. Then cos pi is nothing but -1. Right. Cos pi is -1. Cos 0 is 1, but cos pi is -1. So this will become a number, minus is coming this side, A and B. So this is another property of dot product. Okay. Then we had studied that like cos theta is equal to A dot B divided by magnitude of A, magnitude of B. Right? This is nothing but, if this is the equation 1, this is just the same equation. How much is cos theta? Is dot product of A by B by magnitude of A, magnitude of B. So what is theta? Theta is cos inverse of this. Okay. So this is one of the very important things. Then another thing we have told, like I dot I is a unit vector. Okay. So earlier what we told, if A is a vector, unit vector is nothing but vector A divided by magnitude of A. Right. That becomes a unit vector. Okay. So I dot I is equal to J dot J cap, J is equal to K cap dot K. So is equal to how much? Is equal to 1. Why? Because the angle between unit vector I and I is equal to 0. So this become 1 into cos 0, which is equal to 1. So this is a very important thing. But I cap into J cap is equal to J cap into K cap into K cap into I cap is equal to 0. Why? Because if this is I, if this is J,
theta is 90.
And this is K, then theta is equal to 90 degree. Okay? So it will become I magnitude plus J magnitude, I cap magnitude, J cap magnitude, and then cos 90 is equal to 0. So why? Because 1 into 0 is equal to 0. So this is very important. Okay. So this is another thing. Then I have told you the derivation of A dot B. I have told you what is the derivation. So let us say a vector A is equal to, you just write A1 I plus A2 J plus A3 K. Right? So a vector B is equal to B1 I plus B2 J plus B3 K. Okay, so if these are the two vectors, then their product is nothing but A1 B1
plus A2 B2.
A1 B1 plus A2 B2 plus A3 B3. So this is the product of A dot B. How we got it? Like say the first term we will get as A dot B is equal to A1 I into B1 A dot B, we are writing A1 I dot, okay?
Yeah.
B1 I plus B2 J plus B3 K. This is one term, okay? Similarly, so I when you multiply it becomes A1 B1. But if you multiply with J, it becomes 0. If you multiply with K, it will become 0. So these terms will become 0. So similarly, you have B1 J, right? A to J, right? A to J, right?
Yeah.
A to J into again B1 I,
B2J,
B2J and B3 K. Okay.
Yes.
So this is another term. Then A3 K into B1 I, B2 J, B3 K. Okay. So this is what the total bound, isn't it? So what will happen? Like when J into J will remain remain, and other things will become 0, right?
Yes.
And Ij will become 0 and K into K will remain. So what will remain at the end? A1 B1, A2 B2, A3 B3. So these are the things which are going to remain at the end, right?
Yes.
So from this you know that A dot B is equal to A1 B1 plus A2 B2 plus A3 B3. Then A magnitude, B magnitude. This is very important to calculate the angle between two vectors. You can get n number of numericals in this. Okay, then another important concept is projection of a vector on a line. Okay, so let us say, and this is let us say projection of a vector on a line. Suppose I have a vector A and I have a vector B. What is the projection of vector A on vector B? How do I find out? I will not tell these things 1,000 times. I have already told. You have to listen to it carefully. If you are not able to understand, ask me.
Yes.
But just don't nod your head without understanding. Otherwise, it is complete wastage of effort. I am not telling any Newtonian science that one cannot understand here. Okay. So what is the projection of vector on a line? Okay. What is the formula for projection of a vector on a line? Okay. So let me say I have a vector A and I have a vector B. I have a vector A and I have a vector B and the angle is theta. So what is the projection? So projection is so projection of A on B is this value, right? this value. I have dotted line. So projection is you draw a perpendicular and find out what is the value. Okay.
Yes.
So that projection is or of A on B nothing but A cos theta. That is a projection. Okay.
Yes.
So if we don't know the angle between two, but you want to find the projection of that.
Have to
So,
transpose that.
So A, this cos theta is nothing but A dot B,
By magnitude.
magnitude of A, magnitude of B. That is the cos theta.
Cos theta.
So A dot B.
No, you will get A dot B by magnitude of B when you transpose from dot product formula. There A dot B is equal to magnitude of AB cos theta. So A cos theta is A dot B by magnitude of B.
Okay, let us see. So A dot B is equal to A B magnitude of A magnitude of B into cos theta. Okay, that is A dot B. Okay. Then okay. So let us try it this way. Okay, projection we want to find. Okay. So projection we know A dot B is equal to A B cos theta. Okay.
Yeah.
Right.
Yes.
So we know projection is equal to A cos theta. Right.
Yes.
So without going into that complication, we know projection is equal to A cos theta. So A cos theta is equal to A dot B
by magnitude.
divided by magnitude of B. So this is another important thing. Any numerical it can come. So what are the important things to remember in a dot product? One is the angle. So this A1 plus B, A2, A1 B1 plus A2 B2 plus A3 B3 by magnitude of A into magnitude of B is equal to the angle. So this is one important thing you have to remember.
Cos theta formula.
Then how to find the angle between these two. So without knowing the angle, how to find the projection?
Okay.
This gives another equation. Without knowing the angle, you know vector A or vector B. How much is the projection?
Okay.
Here, without knowing the angle, you know vector A, vector B. How much is the angle this formula will give?
Yeah.
So this formula will give how much is the angle between two vectors without knowing the angle. This formula will give the projection of one vector on another vector without knowing the angle. So this is formula for angle without knowing the angle. This is the formula for projection without knowing the angle. Correct?
Yes.
Correct. And what is A dot B? This derivation you should be able to do. This is 3. A1 B1 plus A2 B2 plus A3 B3. So this is how it is. Okay. And then another important thing, I into I is equal to 1. I dot I is 1, but I dot j is 0. Because the angle between unit vector is 90 degree.
Cos
Okay.
90 is 0.
Cos 90. So these are some of the important things one should always remember. And then if you want to know like how we utilize this formula, like A1 B1 is equal to A2 B2. Like say A is equal to, let us say 1I, okay, 2J plus 3K, right? Then B is equal to, let us say 2I plus 4J, just 2 times, okay? Then 6K. That means, what does it mean? Like when they are just 2 times, that means they are parallel to each other. There is no angle between them. So in this case, A dot B is A dot B vector is equal to A1 B1 means 1 into 2 plus 2 into 4 plus 3 into 6.
By magnitude.
So this is A1 given, so it's A dot B. Okay. So the homework for you is find out the angle between A and B. So that the catch is cos theta is equal to like say A1 B1 A2 B2. So which how much it is? 2 plus 8 plus
20.
18, right?
Yes.
18 plus 8, 26 plus 2, 8, 28. Okay. Then,
By root of magnitude of A and B after find.
so by root of square root of 1 square plus 2 square plus 3 square. 1 square is 1, 2 square is 4,
14.
5, okay, 14. Okay. Then other one, 2 square is 4, 4 square is 16,
56.
16 plus 4, how much? 20,
56 you'll get.
20 plus 36,
6.
56, 56 square root, okay. So now, how much it is? Like 28 divided by, so 14 square root which is 14, then 4 square root which is 2,
2.
okay. So it becomes 28 by 28 which is equal to 1. So if that means cos 0 is equal to 1. That means angle between these two vectors is 0. That means if two vectors are just, one vector is just twice the other vector. Let us say this is another vector, this is another vector. So let us say this is 1i plus 2j plus 3k. Okay. And this is 2i plus 4j plus 3k, 6k. So this is just twice this length. So what actually this is a scalar multiplication. What I am doing? I am just multiplying the vector by a scalar 1i plus 2j plus 3k. It's just the length is changing, the angle is not changing. That's why it's the angle between them is 0. Okay. So you can take a picture of this. So we have covered the dot product comprehensively by giving all kinds of examples. So you have already solved many numericals on dot product. Yeah, so the example of dot product was the work done. Okay, so that's the projection I was talking about. Like just a second. So I was telling you, like I was explaining you. Let us say you have a block. Okay, so you have a block. You are just moving this block. You are applying a force at an angle theta. Okay.
You are done.
Yeah. So you are applying a force at an angle theta. Okay. So this block got displaced from by a distance d. Okay. So the work done is equal to the component of force F in the direction of displacement. So what is that component? That is A cos theta into d. Right?
Yes.
So this is nothing but magnitude of vector F, magnitude of displacement d into cos theta. So that means work done is nothing but a dot product of two vectors, force and displacement. So work done is nothing but dot product of two vectors, force and displacement. So this is an example how in physics or in engineering to calculate work done we use the concept of dot product. Okay, so in the next class we will start cross product. Okay, let us assimilate this much concept now. Then after this we will do the cross product. Okay.